Hello, ladies and gentlemen. We've made it. We're down to the final two questions on the 2004 Cayley contest. We've got question number 24, that's this video, and 25, which will be the next video, and that'll wrap up this contest here. So let's take a look. Four identical isosceles triangles, AWB, BXC, CYD, and DZE, okay, are arranged as shown, with points A, B, C, D, and E lying on the same straight line. Nice. A new triangle is formed with sides the same lengths as AX, AY, and AZ. Okay, so it's not an actual triangle that we can see in our picture. They're just taking these lengths and they'll sort of take them somewhere and arrange them into a triangle. Okay. Already, by the way, I'm starting to think, how are we going to calculate this AX, this AY, and this AZ? I think probably maybe heights and some right angles or something like that, because these are isosceles, so altitudes are right angles, and they go straight through the middle. Anyway, if AZ is equal to AE, okay, so we got another sneaky isosceles triangle here, and it'll actually be, because angle E is common, I believe it'll have to be similar to all these guys. That might be useful. The largest integer value of x, these lengths here, that the area of this new the largest integer value of x such that the area of this new triangle is less than 2004 is, okay. So, ultimately I think what we need is probably an equation in x for the area of this new triangle. And I'm starting to think, okay, new triangle, the AX, AY, AZ lengths. I can't, the triangle isn't really in the, we can't construct it just from like drawing lines in the picture. So right now I'm thinking, how do I get area just based off these lengths? And until I learn something new, like AX, the new triangle is isosceles, or it's right angle, or something like that. Until I learn something new, maybe know one of its angles or something, I really have no idea how to calculate this area other than Heron's formula, which might be something new to some of you, so I will write it down in the notepad here. But Heron's formula is a way to just calculate, we'll do it over here, calculate the area of a triangle if all you know is the side lengths. This is pretty nifty. It works for some quadrilaterals as well. It's got to be a cyclic quadrilateral. I'm not going to mess with that right now, but so this is called Heron's formula, and when all else fails, S here, by the way, is called the semi-perimeter, because you just add up the whole thing divided by 2. And this formula here will get you the area. Now, my gut reaction is probably this isn't what we need to use. Maybe we can use it, but my gut reaction is that this isn't what we want to use, simply because it's a grade 10 level multiple choice contest. I mean, if it was the format, I'd say maybe. If it was the Euclid, I might be inclined to think that. But this isn't something that's really stressed in high school, this formula, at least not in North America. So it's not really something, it's not really an available avenue to everyone. And they try to design these contests so that just about anyone who's going through the school system has a decent shot at doing every question. So while that is something that springs to my mind, which I like sharing with you guys, part of knowing how to deal with these questions is knowing how you think about them, and so I like sharing how I think about them. So this is the first thing that jumps into my mind, just because I don't know anything else about this big triangle that's formed with AX, AY, and AZ. They are just 3 lengths. I could probably work out them in terms of X, maybe, but to me they're just 3 lengths. And when I just have 3 lengths and I'm talking about area of a triangle, this formula is always what springs to my mind. Okay, I'll write it down. Just in case I have forgotten. I don't use it a whole lot, so it's entirely possible that I've missed something in here, but I bet money I didn't. But if you want to, Heron's formula, it's a good thing to look up. It helps every once in a while, but it's not a big thing on Waterloo contests. All right. So we would like an area in terms of x. That way we can say, oh, this formula in x is less than 2004. And I would guess x is a length, and we're talking about areas. I would guess we're probably going to get some sort of quadratic formula in x. And then, that's not that bad to say this is less than 2004, figure out some x values, and get integers. We want the largest integer value of x. So it remains for us just to get a formula for this area. So I think what we should do is probably take a look at ax, ay, az. How do we calculate them? As I said before, I think probably right angles with altitudes in these isosceles triangles is the way to go. So see what I can draw in terms of a good picture. That triangle's too wide. Let's try a little slimmer. Oh, that's much better. That's looking like a great diagram there. I'm proud of that. Alright, so A's over here. We've got little X's all along. And we have X, Y, Z. You'd think they could have said something like P or S for the side length, but whatever. So this AX distance here. Well, I think if I drop an altitude right here, I'll have a height H, and this distance here will be X, and because it's this is isosceles, BXC is isosceles, it splits it into X and a half X. So we get 3x over 2. Okay, so by Pythagoras, since this is a right angle, I can say ax squared is h squared plus 3x over 2 squared. Now, I don't know what this height h is. I don't know what x is. I probably want to eliminate this h somehow, somewhere. Yeah, so let's get this. Probably the extra information that AZ is equal to AE will help us narrow something down at some point. But we can do the same thing with AY. Because it's isosceles, dropping the altitude splits this in half. It's a right angle because it's an altitude. So now we still have H. But now this time we have 2 x's plus a little half x right here. So AY squared is h squared. I think h will probably drop out of the equations or something like that. But we have 2 1/2 or 5/2 x's all squared. And now the last one, we get the same sort of thing. I've been using dashed lines, haven't I? So let's be consistent. So now we're going to have 3 1/2 x's. H squared. So this is all just by Pythagoras and counting how many x's we're dealing with. But AZ is equal to AE, and AE is quite simply just 4x. So I think from here we can isolate what actually H is. We can get H in terms of S, and then that'll get us, once we have H in terms of X, then we can go back and get a X in terms of X, a Y in terms of X, and we already have a Z in terms of X. It's just 4x. Okay, so I think this is a good way to go. All right, going back to the question. So we have 4x squared, so that's 16x squared is h squared plus, and now it's 7/2 x squared, or 49 over 4x squared. So h squared is going to be 16 minus 49 over 4. 16 is 64. 64 over 4. And the difference between those two is 13? No, 15. 15. Yeah, because it's 7 squared and 8 squared, so 7 plus 8, 15. Okay, so 15 over 4 x squared. That's what h squared is. So now ax squared, he was h squared plus 3 halves squared, which is 9/4 x squared. But that's going to be 15 over 4 x squared plus 9 over 4 x squared. That's going to be 24 over 4 x squared, or 6x squared. And ay squared is going to be h squared plus, now it's 5 halves squared, so that's going to be 25 over 4. So that's 15 over 4 plus 25 over 4. So that's going to be 40 over 4 x squared, which is going to be 10x squared. So we could square root each of these, but actually, ax squared is 6x squared, ay squared is 10x squared, and if we bring him back just for a second, az squared is 16x squared. And to the keen mathematical mind, we realize that 6 plus 10 is equal to 16. So ax squared plus ay squared is equal to az squared. So by computing not only these lengths in terms of x, which I would have needed anyway, even if I was going to just jump to Heron's formula, but by computing these lengths in x and arranging them this way, I realize ax squared plus ay squared plus is equal to az squared. That means it has to form a right-angled triangle. So ax and ay, that's base and height right there. And that gives me a much faster way of computing the area. Okay? So it turns out there was a trick that we did learn information about the triangle so that it eases our calculation. If we didn't notice this and we did use Heron's formula, we'd still be fine. But you're not required to know Heron's formula. So catching something like this, thinking, oh, there must be some trick. Is it right angled? Is it isosceles? What have we got? Can definitely help you here. Okay, so our new triangle is a right triangle. We get az over here, we get ax over here, and ay over here. The area of this new triangle, which we want to be less, right? Less or less than or equal. No, just less than 2004. So that's going to be ax times ay all over 2. Base times height all over 2. Okay, so ax is root 6x, just square rooting these. And then square root 10x all over 2. So we're going to have a root 2, root 3x, a root 2, root 5x. The only reason I'm separating those out is because these root 2's will cancel out with the 2 on bottom. And we'll be left with square root of 15x squared. So that's the area. And now I want square root of 15x squared less than 2004. Okay, so x squared is going to be less than 2004 over square root of 15. And at this point, I'm going to have to grab my calculator, most likely. Actually, I think I might be able to do it without a calculator. If I square both sides, the relationship should still hold. So x to the 4 is less than something, and then I'd be looking for the greatest power of 4. I'm going to see, just because I got the time, it's my video. I'm going to see if I can do this without grabbing the calculator, although I admit, 2004 divided by square root 15, what's the biggest square less than that, will get us the answer right away. But just as a little mental challenge, if I forgot my calculator, could I still do question number 24? So x to the 4 must be less than, and now I'm falling at the first hurdle because I don't think I can square 2004 really quickly in my head. Actually, 4,000, I think it should be this. Just double check really quickly. 6108 And then 0, 0, 0, 8. So I did make a mistake. It should be a 16 here. And then 0, 0, 4, 16, 0, 16, 0, 4. Okay. So now I'm looking for the biggest power of 4 less than that. Well, actually, I can bring the 15 over once again. No, let's long division this. Let's long division this sucker. 15, 4, 0, 1, 6, 0, 1, 6. Okay. 15 goes into 40 twice. Written down a 30. There's a 10. 90. So that's 6. And then we get 90 here. And that gives me 111. So that's 105. So that's a 7 here. Once again, another 105. We got a 51. Let's bring it up here. We bring the 1 down. We get 51. How many times does 15 go into 51? 3. 45, and then we're left with 6. 6 and 4. Okay. So I need the biggest power of 4 less than 2, 6, 7, 7, 3, 4. Not too appealing, but let's see if we can break it down. So here's 10,000. So I can definitely do 26 copies of 10,000. Biggest power of 4 less than 26 is 16. So we're looking at something like 40 to the power of 4. No, not 40. 20 to the power of 4. 20 to the power of 4 is 1600. What else could we have here? So it's definitely between 20 and 30. Does that narrow it down in terms of our responses? So it's either 21 or 22, it's looking like. Well, I see no reason not to just multiply these out. 21 squared is 441. We'll do another 441. So that's 441, 0, 4, 6, carry the 1, and then 7, 1, and then another copy of that. Eight, 14, 14, 1, 9. Okay. And now, it's almost got to be 22, doesn't it? But we'll just double check. So if 22 is too big, then we know our answer is going to be 21. Without using a calculator. That was the whole point of me trying to do it this way. 9, 1. Okay. 0, 2 with the 3, and that's 67. And now 8 and 3. 0, 0, 6, 3, 9, 1. 6, 5, 15 and 7 is 22. Carry the 2, so that's 10. That's a 4, 1, 3, 2, 3. Okay. Again, these are seeming kind of low, but 23 squared is probably going to be too big. Yeah, 23 squared is 5, 2, 9, and already that's looking like we're going to have a 25 at least. Carrying some other stuff over, it'll probably be bigger. All right, so I'm saying the answer is E22, but I admit that took me a while because I'm just doing calculations. Let's go back to it. I think my answer is 22. Let's see if the by hand without a calculator method works. I can clear a page, can't I? So let's just jump into it. What would we have done if we just had a calculator, which I do have a calculator sitting here. But every once in a while I like to check my mental math and my ability to just do arithmetic on the page. So I'm just going to take 2004 divided by square root of 15. And yeah, so x squared's got to be less than 517, and the biggest square less than that is 484, so 22. So it really is the answer. But, you know, some of you out there might be saying, well, that you just wasted, what was that, 2, 3, 5 minutes of my life watching that. One, you didn't have to watch it, so don't complain like that. But more importantly than that, it's a good idea to be able to say, can I do this without a calculator? I see a lot of students in university, and we're talking not just first year, like second, third year university, who reach for their calculator because they can't do the calculation. Not that they don't want to. I mean, we can all agree that took a while, and if we had a calculator, yeah, we should have. But they reach for their calculator because they can't do it. Because they have gone through their entire mathematical careers just relying on this device. And I'm not going to say something like, what are you going to do when the calculators all fail in the world? Because that's not going to happen. We're not going to reach a world where calculators are going to go away or computers are going to go away. But you have noticeably lost a basic skill when you can't do something like this, when you can't even sit down and think, how would I do this? I had to use long division. I don't use long division. I haven't done long division since like grade 4. But I used it. I employed it because I remember how to do it. And I'm seeing people in their 20s, and they don't remember how to do long division. And that's worrisome. Anyways, PSA over. If you didn't have a calculator, you still would have gotten 22. Calculator, obviously faster, and it's allowed on this contest. So, you know, no worries. It's E. We're done. I'll see you guys for question number 25.